Hello. In this video, we're going to look at graphical features of categorical distributions. Okay, so let's start off by discussing it relative to numerical distributions. So with numerical distributions, we had shape, we had center, and we had variability. So shape and center don't really make sense for categorical distributions because the order is arbitrary. So you could go through and reorder, and those wouldn't make sense because they would only you'd get different shape and a different center based upon the ordering. Okay, so let's just write that down. So shape and center do not make sense for categorical variables. Oops. Let's write the first time. For categorical distributions, since the ordering of the categories is arbitrary. Right. However, we still have the idea of a typical outcome, which is not necessarily the same as center. They were the same for numerical distributions, but they are not the same as for categorical. So we can still discuss typical outcomes and variability. Okay, so with that in mind, we are going to talk about the mode. So we mentioned the mode in the video on numerical distributions, and we said that it wasn't really very helpful. It doesn't really work very well with numerical distributions. The mode is ideal for categorical distributions. So we are going to go through and use the mode here, and the mode is going to end up being our value for the typical outcome. So you may ask, is this true even if you have a very widely distributed, a very wide distribution with a lot of different possibilities, and the mode is the thing that occurs the most often is a very small percentage of the total possibilities? Yes, it's true. Even in that case, we still are going to call that the typical outcome, even if it were not highly likely, because there's so many different possibilities. So one more comment on the mode, and that is, what do we do if there are two things that both share the same number of where two things have the same number of outcomes and they're both the highest. What do we do then? So we are going to retain the idea of a bimodal or a multimodal distribution. So if you have two things that have the highest number of outcomes, then we say that the distribution is bimodal. And if you have more than two, then we say it's multimodal. Okay, so I have bimodal, two categories, share the highest number of outcomes. And multimodal more than two. So one thing to note here, they has to be exactly the same. So you can't have, it's not bimodal if you have two like little peaks. Why? Because the order is arbitrary. So if you change the order around, you could make it so that there aren't two peaks. And the same thing goes for multimodal. So it's bimodal if you have two different categories, both that have the highest number of outcomes. Okay, and they have to be the same to both be the highest. All right, and the same thing goes for multimodal. We have more than two. So let's look at a graph and just talk about this for a second. Okay, which is the one we're going to look at first? All right, so we're going to take a look at this one. So here you can see we've got two different distributions. These are both categorical. The possibility, so these represent the percent of respondents who chose what they thought that their economic class was in 2008 versus in 2012. And so you could see some say they didn't know, some say they were in lower class, some say middle class, and some say upper class. And same thing for 2012, don't know, lower class, middle class, upper class. So if you're going through and you were studying this and you were to go through and give the typical outcome, which is the mode, what you'd say is you'd say that the typical outcome or the mode is middle class in both of the two distributions. So because in each case the middle class is the highest bar. So the highest bar is going to be the mode. That's going to be the typical outcome. So we would say that this is typical. And same, right? So one piece of information you could use in terms of your study is how tall the modes are when going through and evaluating. And so if you look at this in 2008, the mode looks like slightly above 50%. And in 2012, the mode was slightly below 50%. So that's a piece of information that you might want to convey if you were going and you were analyzing this. So it shows that the middle class has decreased in size from 2008 to 2012. If you look, you can see that the lower class has increased and the upper class has decreased as well. So upper and middle are declining and lower is increasing in size, which is a worrisome trend, when it comes to analyzing the welfare of people of whatever country. I think this is probably the United States, but whatever country was being studied, that's not a good sign for the future of that country, of the welfare of its people. All right, so let's see, was there another graph we were going to look at? Okay, no. So we're just going to jump over to our next topic, which is variability. So when we're interpreting the variability of categorical distributions, the term that we're going to use, or the way that we're going to think about that, is in terms of diversity. Let's write that down. diversity, that's the term we're going to use. Diversity or variability, those are kind of the same idea. And by that, what do we mean by diversity? So the question is, are observations, are the outcomes that we get, are they largely in a single category, or are they spread out over multiple categories? So if they're all in a single category, that's not very diverse, if everything's just of one type. And if they're spread over multiple categories, then that would represent more diversity. Okay, let's pull up an example. Okay, so here are percentage of students at 2 different Los Angeles schools divided over ethnic groups. So, and this is actually frequent when we talk about diversity, we talk about ethnic diversity. So it does kind of fit with the example, or sorry, with the title of the topic. And so if you look at these two, you could see, first of all, that there's a multitude of different possibilities at school A, right? So we've got 1, 2, 3, 4 different categories that have at least some significance there. I mean, there's tiny numbers in these other categories, but we do have 4 different categories that are of some significance, whereas school B essentially only has 1 category. So if you were to go through and think of this in terms of the diversity of the ethnicities at the school, you'd say that this school is significantly more diverse than this school. This would be diverse, and then this school is not very diverse. And so we're using diversity to represent variability. You could also kind of just extend that idea. If a categorical distribution is diverse, then that means that it has a lot of variability. There's a lot of different outcomes. There's a lot, there's a lot of variation, in the possible results. And so you'd also could say that since this is diverse, it also has a lot of variability. It also has a lot of variation in terms of the information that was collected. So if you were to go through and actually look through the survey data that was collected, you'd see Hispanic a bunch of times, you'd see Filipino a bunch of times, you'd see white, and you'd see Asian a bunch of times. So you'd see a lot of different possibilities. And so there's a lot of variation in terms of the data itself. Meanwhile, if something is not very diverse, that's another way of saying that doesn't have much variability. And so if you were to go through and look at the actual data itself, there's not much variation. Everything looks the same. And so this just gives you a visual impression of variation, and that is the taller. If you have a single tall tower, that represents very little diversity, and if you have a lot of towers or a lot of bars, then that represents diversity. Okay. So let's that covers variation for this for those 2 charts. Let's look at another pair here. Okay, so here's another pair. This pair represents the possible different outcomes if you were to go through and ask a class or ask a group of people, what their class is, what their standard of living is, and it represents the 2 extremes. So the point I wanted to make by showing you this is, what do the 2 extremes look like? So one extreme is where everybody is the same. If everybody goes through and they fill out the survey data and they're all the same, then there's no variation in the data. there's no diversity. Everyone is identically the same. Meanwhile, the opposite of that would be if everyone is different, the maximum amount of variation. So the opposite extremes are you have a single tall tower that represents uniformity, no diversity, no variability, no variation, or you have the ultimate amount of diversity where you have equal amounts in the different classes. So I mentioned this in the last graph, and we'll go back to it in a second. But the thing that can be confusing about comparing graphs is when the vertical axis is not the same, right? So if you're wondering, wait, there's a single tall tower, and yet it only represents 25% of the possibilities. How is that accurate, right? Because these are all 25%. Well, it doesn't. It represents 100%. It's that the y-axis on this graph goes up to 100, and the y-axis in this graph only goes up to 25. So these are not the same height. If you were to go through and put these on the same set of axes, then these would be 1/4 as tall as this tower, right? So if you were to go through and put them on the same axis, you'd go through and they'd all have a height of about 25. So you'd have something like, something like this. That's what they'd look like if you went through and put them on the same table. So these 4 bars would be at a height of 25, right? And then this one goes up to 100. So it's something to be careful about is when comparing distributions, make sure that the y-axes are the same height. It's really easy to get thrown off by that. Let's just jump back to the last graph, because this was true on the last graph as well, and I just forgot to mention it. Okay, so we're back over to this one. So notice that the height here of the tallest ethnicity is under 50%, right? So we've got something like, I don't know, we could say this 47%. And so you say, oh, 47%. Well, this one looks pretty close to just as tall as that. So that must be there's 47% Hispanics. What's the rest? Well, no, it's not 47. That's the y-axes are different. This guy here looks like it's about 97%, right? Maybe you've got 1% African American. Oh, well, maybe it's 99%. Anyway, you get the idea. The y-axis can have a different height, which can make it confusing. If you were to go through and put these on the same axes, then this bar here would have a height of around 50%. So it would be down here. Okay, and so that's just something to watch out for when you're going through and doing comparisons. Okay, so let's just do a quick summary here. So if you're describing distributions of categorical variables, what do you want to do? What should you do? Oop, not variation, sorry. Describing a distribution. So there's 2 things you should look to do. One, the typical value, or the mode. And if there are multiple values that are the highest, then you'd say bimodal or multimodal, depending upon how many. And then 2, you want to go through and you want to say something about the diversity or the variability. Okay, and so that's the idea of looking. And do you have a single tall tower that all of the information from your data fits into? That would be not very diverse. Or do you have lots of tall towers, lots of tall bars, and then you'd have the data spread out, which would be a lot of variability or a lot of diversity. All right, and before we finish up this video, let's go through and actually do a couple comparisons, just interesting. Actually, a couple of, this is just really just one. So here we've got a comparison. These are causes of death for men and women. And they just, it's just interesting data to look at. So if you go through and evaluate this, what would you look for? What would you think about? All right, so you'd say the typical value or the mode in both cases are motor vehicle motor vehicle accidents. Okay, so that's one piece of information that you'd give, that you'd say, okay, they're both motor vehicle accidents. However, one thing you might think to mention is if you look at the size of the motor vehicle, the how tall those bars are, the motor vehicle accidents for men is at about 35 deaths per 100,000, and for women, it's at about 16,000. Again, that optical illusion strikes again, where the bars look like they're the same height, but the y-axis here goes up to 40, the y-axis here goes up to 18. Okay, so you mentioned the modes in both cases. Maybe you mentioned the relative heights of the modes. And then the next thing you think about is the variability. And so we're comparing these. So the data has a fair amount of variation. Certainly motor vehicle accidents is pretty tall, but you've got, if you took all these other categories and piled them up, they'd be taller than motor vehicle accidents. So there's a fair amount of variability in both. But if you were to go through and compare them, which has more variability, what you want to do is you want to compare the heights of the bars that are not our single tall bar, and think about how much think about which one has more tall bars relative to the other. And so you could see other accidents and homicides and suicides are very relatively low for women compared to men. And so that means that there's more variation in the men, right? There's more possibility for different outcomes when you're looking through the data. It's more likely that you'd get an other accident or a homicide or a suicide with men than you would with women. And then for the other two, diseases and other, they do somewhat offset because these two are a little bit taller than these two. But in terms of just variation, certainly there's more spread here than there is in this data set. This data set is women is kind of combined in motor vehicle accidents, diseases, and other, whereas men is more spread out over all 6 categories. Okay, and so that's what you'd say about variability. There's more variability amongst men than there is amongst women. Okay, so one thing you can do when you're comparing 2 graphs like this, in which I kind of illustrated on an earlier one, is if you want to compare the heights, you can put them on the same axis, which I did do in an earlier graph. So let's take a look at that, because the book actually does this for us. It's kind of nice if I can find it. Here it is. All right, now they're on the same axis. Okay, and so now you can go through and compare them, compare the deaths for men versus deaths for women. And one of the overriding observations that I would think that you would make when you look at this data is that men are far more likely to die of these different causes than women. You could see motor vehicle accidents, men, it's about twice as tall. Other accidents, I don't know exactly what those other accidents could be, but the bar's about 5 times as tall for men versus women. Homicides, maybe, whatever, about 4 times as tall. Suicides, the only things that are relatively equally likely are diseases and other. And so this question was posed, so I haven't mentioned it yet, but this question was posed in the text in the, related to the fact that women have a much higher, much longer lifespan than men do. And so one of the outcomes that you could get from looking at this chart would be to go through and say, yeah, well, men are much more likely to die than women are. And so that's why, well, obviously people are equally likely to die, but you have all these accidents, all these different accidents and similar types of things that cause an early death are much more likely in men than in women. And so that's why women live longer lifespans than men do. Okay. And so, yeah, so anyway, that's something to watch out for, is when you have the, to go back to that previous graph, I've mentioned it a couple of times now, but it's that important a result. When the bars are the same height, you've got to check the y-axis to make sure that the y-axis is similar, to be able to go through and compare them, when looking at the height of the bars alone. And I'm going to illustrate that with one more example as well, because this is a tricky thing that you regularly see. So what this represents violent crime over a series of years. I don't remember if this is nationwide or if that's probably nationwide because it's in millions. And so if you go through and look at this, if you look at the graph here on the left, and someone were to ask you, how does it look that violent crime is trending over time? It looks at a glance like you have this tall bar that goes down to zero. It looks like violent crime has gone to zero. Like there's no violent crime. It's gone away entirely. You know, it's down by 95, 98% over this 5-year period. So we started in 2007 with whatever, if that bar, I don't know if you want to say that's a tall lot, if that's a lot of violent crime. But whatever we started with, whatever that was, whether it was a lot or a moderate amount, from there, we just went bang, straight down, crashed. Violent crime is completely gone. Well, oops, they tricked you, which is, again, this is something you've got to watch out for. And what the tricky thing in here is that the bottom here is not at zero. This is a common tactic when it comes to trying to fool someone who's a casual observer of statistics, of the chart, is to go through and do something like this where the bottom is not at zero. If you go through and redraw, this is the same data, but you've gone through and you've put zero at the bottom, then you can see over the 5-year period, we've only seen a relatively small decline, which maybe is not really that significant. So one graph makes it look like we went from a fair amount or a large amount, whatever starting position there was for crime, and it just crashed and went straight to zero. The other one makes it look like there was a slight decline. Violent crime is down by maybe 10%. And so that's how you can tell two completely different tales by the way in which you go through and represent the visual representation for the data. Okay, so something to be very, very careful of, which I've stressed now with like 4 different graphs, is make sure the y-axis is appropriate when comparing things, is appropriate when graphing things. The y-axis is just really that important. And so it needs to be one of the first things that your eyes focus on when it comes to looking at interpreting graphs of data. Okay, so that covers everything in this video. Thank you for watching. I will see you next time.